Hello everyone, welcome to Codecraft. Today we are going to discuss about top 5 interview questions for senior software engineer in 2024. Question number 1, explain the GIL global interpreter log in Python. How does it affect multi-threading? This is the most asked question which has been asked in many interviews. We will discuss in detail. I have prepared the notes for you. You can pause the video and understand it correctly. Correct. Question number 2 is design a thread safe cache in Python. So as you all know, Python is a single threaded language. It cannot execute 2 bytes code simultaneously at the same time. So how we can design a thread safe cache in Python? Question number 3, how does Python garbage collection works? Question number 4 is implement a decorator for retrying a function upon a failure. If a function is getting failed, how you can retry? So you need to write a decorator. And the last question is explain and implement a Python context manager. These are the most asked questions in 2024. Let's discuss the first question first. So what is global interpreter log? It is a mutex in C Python that protects the access to the Python objects, ensuring only one thread executes Python bytecode at a time. So as I already told, that Python is a single threaded language and it cannot execute bytecodes, 2 byte code at the same time. So to prevent that, Python introduced global interpreter log. It simplifies memory management by avoiding the race conditions, which bytecode will get executed first, which bytecode will get executed second. That will be decided based on the global interpreter log. So what is the effect on multi-threading? So IO bound tasks. For IO bound task means file IO, network calls, like if you are connecting to database, if you are accessing a other API, or you are reading some files from the disk. So anything which is you are accessing outside of your process is called IO bound task. In multi-threading, in IO bound task, multi-threading works well because thread release the log during IO. So when the IO is happening, so when you are going outside of your process, at that time it releases the log and multi-threading can work properly in this case. But for CPU bound tasks, the log prevents threads for executing simultaneously. So 2 bytes code cannot be executed at the same time, leading to suboptimal performance. So to achieve this performance, there are 2 workarounds. One, you can use multiprocessing specific. So if you are starting multiple processes, then you can bypass the log and you can utilize the multiple CPU cores of the machine. The other method is you can use async IO for IO bound operations to maximize the concurrency without thread. So you do not need to use thread, you can use asynchronous programming to maximize the concurrency. Correct? So let me know if you understand the concept correctly of how global interpreter log works in the comment. Second question is design a thread safe cache in Python. Let's switch to code editor. I have already written the code. I will explain you line by line how we are going to achieve this. So this is the code. So what we have done, because we are going to implement thread safe, so I have declared a class which is called thread safe cache, and inside constructor I have initialized a cache location which is a dictionary. where we will store our cache based on key value pairs. And I have initialized one lock from the threading library, so that if one lock is applied, other threads should not be able to access the same object. Correct? So we need three methods inside this cache. One is set, by which we will set the uh, key value pairs. Get, by which we will pass key and we will get the cache from the cache storage. Right now we are using memory cache, which is a dictionary. And then you can use a delete method to delete the cache if you want to do so. So one way that you can define a TTL inside when you are setting a cache, and based on TTL it will get delete automatically. Or you can call delete method to delete a particular key from the key cache from the cache store, which is our memory, which is a dictionary. Correct? So what we are doing, we have defined cache, we have defined lock. Now we are calculating the expiration. So after how much time it will get expired. So time dot time, the current time, and then plus TTL. It is in seconds. So now apply the lock and set the key value pairs. So in the value, what we are assigning the value and a expiration also. It's a tuple which will contain value and expiration both. Now when you will use get, you will pass a key and we will apply the lock, so then it is thread safe. And if key is exist in cache, then we will access the value and the expiration from the cache based on the key. If time is less than expiration, then return the value, otherwise delete the cache from the dictionary and return none. The same thing will happen with the delete. So when you will call delete, you will have to pass a key. If this apply a lock for the thread safe, and then if key is available in the cache, then delete the cache based on the key. So how we will use it? We will create an object of the class which we have created, and then set the key, call the set method, pass the key, pass the value, and TTL is 5 seconds. Print the cache. So we will use get method here and pass the key, and then we will wait for 6 seconds because TTL is 5 seconds. So when I will access again, it should return none. Let's run it and let's wait. So first of all, it returns the value, and after waiting the 6 seconds, it returns none. That means it is working perfectly, and we have applied the lock also. So because we have applied the lock in every function, so it is a thread safe. One thread can access the object at a time. Okay, let's move back to our presentation. Question number 3. How does Python garbage collection works? So Python uses reference counting and cyclic garbage collection for memory management. What is reference counting? Each object in Python has a reference count that tracks how many reference point to it. When the reference count drops to 0, the object is immediately deallocated. Cyclic garbage collection. Reference counting fails for circular reference, like two objects referring each other. Python cyclic garbage collector, part of the GC module, garbage collection module, detects and collects these cycles. So how we can debug a memory leakage? Let's switch to the code to understand better. Okay, so how we will check the stats if there is a leakage, memory leakage or not. So let's do it in code. Import import gc import trace malloc and start trace malloc. Here we will detect leak. So what we will do, we will create a snapshot and then we will start a loop and check the stats. Let's run it. If something is running, if you will run this code parallelly, then you will detect the leakage and you can fix it. Let's move back to our next question. Implement a decorator for retrying a function upon failure. So I have written this function and I have explained line by line so that you can pause the video and understand the every line in detail. So what we need func tool. From funcs to function tools, we need wraps because it is used to maintain the metadata of the original function, means the parameters. This is our main decorator which will accept two arguments, number of retries and how much delay we want. Inner decorator function which will accept the original function so that it can be executed inside the decorator. Wrap function, it will also take the function as input and it will retain the metadata of the original function, like this, arguments and k arguments of the original function. So let's define attempts 0, how many attempts we want. While attempts is less than n is our number of retries, return the function, call the function. If exception occurs, then increase the attempts. If attempts is greater than n, then raise the error. Otherwise, sleep for the delay. How much delay we want in every retry. Return the wrapper and return the decorator. How we can use it? We can define a function which we want to retry, right? So this is our function, risky function, and on this function we have applied our decorator. So decorator name is retry. So we are applying at the rate retry. N equals to 3 means we want to try 3 times. Delay is 2 seconds. So when we will call the risky function, we will see how decorator works, right? Go through with the comments for each line why it has been written. Trying every 2 seconds, trying three times it will retry because we have passed n equals to 3, and function fails after retries. It is failed. Value error, because we have raised value error, the function will raise this, print this exception. We can try it by increasing to 5 and increasing to 3. We can run it again, and every 3 seconds it will retry for 5 times, and it will wait 3 seconds in every retry, and after that it will raise the value error and we will catch the value error. We have already applied the try and except block, so in except block we will catch the error and we will print which is failed. Correct? Take a pause and understand it and let me know in the comments if it makes sense or not. Okay, already completed 4 questions from our agenda today, which is top 5 questions for senior software engineer in Python. So this is our last question. Explain and implement a Python context manager. What is context manager? So every time you use with a statement with anything inside Python code, that means you are working with a context manager. So what it contains? It contains two things. What will happen when the context starts, and what will happen when context exits. So how it has been implemented, you if you are implementing a Python context manager, you need to remember one thing. When you exit from the context manager, your resources should get deallocated, which you have created when it enters. So there are two methods, internal methods, which Python provides, which we need to implement. So let's switch to the code and complete it. So I have already written a file manager for you, and I have explained in every line why I have written the particular line. So it's a custom class for file manager, and we have implemented underscore underscore enter underscore underscore, in which we will open our file and will return the file, and on exit we will close our file and will return false. So that is the only thing you need to consider when you are working with the context. So when you will initialize the file manager, I will ask you file name and the mode, in which mode you want to open it. And the same thing we are going to use inside open function, that is self.filename, self.mode. You need to use open the file in the specified mode and return the file, and on exit we need to close the file. So let's see how it works with file manager example.txt w. W means which we are going to open it in write mode, and f.write hello world. So as soon as it will complete the write, it will go into the exit and it will close the file automatically. So you do not need to open the file, you do not need to close the file. So everything, the context will take care of it. Correct. So this is how you can implement the context manager. Let's give it a try. Let's run it. So it returns a file example.txt, which is hello world, and if you will see, it is already closed. It is already closed. After returning the file, it is already closed. File has been closed. Hope you are able to understand the question and the answers. Top 5 questions. Please left me a comment with your suggestions. Thank you.